So good afternoon everyone, this is Samarth. जैसे कि आपको पता होगा टाइटल से that we are starting today permutation and combination, right? So this used to be some of my like toughest topics for me to understand in my daily days, but I, you might know that today. So this topic was like one of the toughest topics for one of the in my grade days. So I hope I do justice to this today. I have like went through a lot of practice with this. So मतलब it's the logic of math कि आप जितना practice करोगे आपको उतना benefit करेगा, right? So same goes for permutation and combination. Also logic should be strong, I suppose. Like logic plays a really major role when starting permutation and combination. You should be really like high on your logical and analytical skills. So starting with permutation and combination, one thing that let's just go through a bit of theory. Also, sometimes people might be scared of permutation and combination just because it has a bit of theory in it. Like it is not that mathematical. Mathematical and by mathematical I mean it's algebraic. I don't think it's that algebraic, but it is very on the side of thinking and logic side. So let's go to the theory part one. So the introduction is saying the main subject of this chapter is counting. Yes, we're going to study counting. Like if you are aware, what counting here is basically counting possible events or not possible events, right? So let's see what it says further. The problem is to arrange some or all of them according to some order or to select some or some specifications. Okay, this was a part of like elaborate definition what do we mean. तो अगर कोई ऑब्जेक्ट है और हमें उनको अरेंज करना है तो एक पर्टिकुलर ऑर्डर में अरेंज करना है तो उसके नंबर ऑफ वेज कैसे हो सकते हैं कितने नहीं गोइंग ऑन ऑल्सो अगर हम क्वेश्चन करेंगे ना तो दैट व्हाट आई एम सेइंग डूइंग परम्यूटेशन कॉम्बिनेशन क्वेश्चन ही आपको हेल्प कर सकता है गेटिंग द आइडिया एंड द फील ऑफ परम्यूटेशन कॉम्बिनेशन सो आई वुड सजेस्ट यू डू दैट एंड लेट्स सी व्हाट फॉर द क्वेश्चंस we have in them fundamental principles of counting. So first is rule of thumb. If a task can be performed in m ways, while a second task in n ways, the the task cannot be performed simultaneously. Then perform task can be accomplished in a total of n plus m ways. So इसका कहना यह है कि अगर आपको काम है a and b, right? Let this be a set and let this be b set. और हमें इन दोनों को इससे m ways से करने के और इसके हैं n ways, right? तो हमें अगर अगर task simultaneously perform नहीं करना है तो performing any of the tasks would be like total of ways would be m plus n. Why is that? because if you see about it, a को करने के m ways है, ठीक है? Let's just make dashes or like squares for understanding it better. So like if we have squares here, like let this be m squares and let this be n squares, right? तो a को करने के n तरीके हैं और b को करने के n तरीके, और हमें पता है कि दोनों साइमल्टेनियसली हमें परफॉर्म नहीं करना, तो एक को परफॉर्म करने के हमारे पास कितने स्क्वायर हो जाएंगे, m प्लस n हो जाएंगे, राइट? Now moving on, what do we have? The rule of product. So if a procedure can be broken down into first and second stages, then there are impossible outcomes for the first outcome, and if for each of these outcomes there are possible n outcomes for the second stage, then the total procedure can be carried in the designated order in total of m and n ways. Very simple to understand. इसमें कुछ नहीं मतलब ज़्यादा इसमें it's like the definition itself is very simple. See, it says कि अगर हम a को m तरीकों से कर सकते हैं, right? एंड b को a के होने के बाद n तरीकों से कर सकते हैं, यानी कि अगर कोई एक टास्क हो गया है a का तो उसके बाद हमें b को करना है तो उसके n तरीके हो सकते हैं, राइट? कोई से भी टास्क है. So if I go with here with this a task and three options, n option, right, for one choice of a. अगर मैं दूसरा चॉइस करता हूँ, अगेन आई हैव n ऑप्शन, तो इसका मतलब क्या हो गया? हर एक चॉइस for every choice in a, I and I have n possibilities. तो इससे क्या बोल सकते हैं, तो हमारे पास चॉइसेस कितनी टोटल, एम। तो इस सबका सम करेंगे तो हमें एम का सम करना है एम टाइम्स तक, तो दैट वुड लुक लाइक एम इंटू एन। आई होप यू गेट इट। नाउ मूविंग ऑन, लेट्स सी व्हाट डू वी हैव। उसके बाद है illustration, like let's see an example. So if there are three stations A, B, C and five routes for giving for going from station A to station B, and four routes from going from station B to station C. Find the number of different ways a person can go from A to C. Simple as that. So let's see. Since you have a condition of going via B, it is a very direct application of product of like the rule of product. So what do we have here is there are five ways, or once we reach B, so we have four more ways, right? So अगर हम यहाँ इस वाले रास्ते से आते हैं, then also we have four options. Second वाले रास्ते से आते हैं इस वाले रास्ते से दो, then also we have four options from this also, from this also, from this also. So how many fours do we have? Five, right? So total becomes 20 ways. Okay. Moving on, a hall has 12 gates. And how many ways can a man enter the hall through one gate and come out through a different gate? Yes, it's as simple as that. अगर हमारे पास 11 gates है, 12 gates है, sorry. So let's draw 12 gates just for the convenience of it. यहाँ पर 12 gates है. अगर मैं एक gate में enter कर गया, then I have to come out of a different gate. So how many options do I have? 11 options, right? अगर मैं इस gate से भी जाता हूँ, then to how many options will I be left with? 11. So it is 12 into 11. Moving on, I have how many numbers between 0, comma 10,000 can be formed by using the digits 1, 2, 3, 4, 5. No digit is repeated in any number. Digits can be repeated. So let's take the first case where no digit is repeated, right? So I have to make it between 10 and 10,000, right? So let's see how does it go. So first we have is I can take any number from these five numbers and any four numbers, like left four numbers. So first, okay, so these are two, let's just systematic way. So what are they trying to say is that I can have left from 11 to 9, 9, 9. This is the possibility that we have, right? So let's see. That means I can take two-digit numbers and four-digit numbers. So let's see. So for two-digit number, what do we have? We can take any number and the rest is this. For three-digit, we have 5, 4 into 3 with no repetition. I'm talking about no repetition here. And for four digits, I can also take any number here. So 5, 4, 3, and 2. This gives me 20. This gives me 60. This gives me 120. And the sum says is 200. So there are 200 ways here for the first case. Repeating this for the no repetition is being allowed case. What changes here is the value of ways. So 5 into 5, because numbers can be repeated here, right? And for 3 we have 5, 5, 5, and for 4 also we have 5, 5, 5 into 5. This gives me 25, this gives me 125, this gives me 625. So what am I left with this is 750 plus 25, this gives me 775. I hope it clears out. This is very basic for you. I know this might be basic, a bit of basics for you guys, but it's good to revise your basics, right? Because you'll get a deeper concept of it and something that your teacher or yourself might have forgotten. So it's good to repeat a bit. Now going back to the factorial notation. So I hope everyone is aware of what a factorial is. There are two representations. We can write a factorial like this as well and like this as well. So what do we mean by this? We mean by this is n minus 2, n into n minus 1 into n minus 2 goes to 3 to 1, right? So yes, now getting to the notation part, let's see what does the definition say. An effective way of writing a product of several consecutive number is a factorial notation, right? That is what a factorial is. The number n factorial, read as n factorial, is defined as follows. जो मैंने अभी बताया, it's very similar. Now moving on, there is another way of writing a factorial. This is something that you should understand. Sorry, I meant to circle this, not that. Okay. Now find the sum of n terms whose series, terms of the series whose nth term is this. So what are we supposed to do is हमें sum निकालना है summation of n factorial into n और n सीरीज का निकालना है. So n goes from 1 to n. तो इसको कैसे कर सकते हैं? हमारे पास क्या है? हाँ, तो अगर हम इसको लिखना चाहें तो हम इसको ऐसे लिख सकते हैं n फैक्टोरियल n प्लस 1 माइनस 1. यहाँ पे उसको ऐसे कर देते हैं, राइट. एंड नाउ लेट ओपन द ब्रैकेट. तो हमारे पास क्या बच जाता है? n फैक्टोरियल इंटू n प्लस 1 माइनस n फैक्टोरियल. तो हमारे पास क्या बचेगा? n प्लस 1 का फैक्टोरियल माइनस n फैक्टोरियल. एंड नाउ वी आर पुटिंग अ समेशन ओवर इट. So n is equals to 1 to n. So let's see. For 1 we have 2 factorial minus 1 factorial. Now we have 3 factorial minus 2 factorial. We have 4 factorial minus 3 factorial. And it goes for n, right? N plus 1 factorial minus n factorial. So by the law of repetition, we are left with n plus 1 factorial 1, right? This is the answer. Let us check. Yeah, this is the answer. Moving on, let's go through another question. I hope it gets you right. Okay, now let's see what do we have. Okay, we have permutation. So, okay, permutation itself might come as a heavy word for many. So, let's see what the permutation is, the proper definition. So, each of the different arrangements which can be made by taking some or all of a number of objects is called a permutation. Okay. इसको अगर हम हिंदी में ट्रांसलेट करने की कोशिश करें तो नंबर ऑफ अरेंजमेंट जो कि हम कुछ या सारे नंबर ऑफ ऑब्जेक्ट्स लेकर कर सकते हैं उसको परम्यूटेशन कहते हैं, राइट. A bit tricky to you. अभी समझ नहीं आ रहा होगा कि what does the definition is exactly trying to say. But on solving questions, I hope it will be much more clearer. So let's see what the definition and representation of a permutation is. सबको पता होगा कि permutation is written by NPR. And how do we write it? N at the like above P and R below P. Like superscript and subscript if you're aware of. So इसको ऐसे लिख सकते हैं n factorial n minus r factorial. This is what our permutations look like. So let's move on. In permutation, the order of items plays an important role. Yes, the order of items plays a very important role in permutation, but in the case of combination, it does not matter. For example, A, B, C is equal to B, A, C for combination, but A, B, C is not equal to B, A, C in case of permutation, right? There are different sets of items. Not different sets of items, but different orientation or distribution, whatever you want to say. Different order of items. So these are different objects for permutation. In permutation, yeah, I have read that earlier. Number of all permutations of n different objects taken all at a time is n factorial. Okay. Moving on. Let's do some practical applications. So it is given to us that 56p let me erase it. The handwriting is really bad. So 56p r plus 6 in ratio with 54p r plus 3 gives me 30800. So I have to find r basically. So I can write it as 56 factorial upon 56 minus r minus 6 whole factorial divided by 54 factorial upon 54 r and 54 minus r minus 3 factorial. So we'll cancel this out and we're left with 56 into 55. And for this part, we have 51 minus r and 50 minus r factorial, right? So this factorial will cancel this factorial, or sorry, I made a mistake here. I suppose there will be a cancellation here. If I write it as 56 into 55, and so I can write it as 51 minus r minus 1 plus 1 factorial, right? So let us see which is bigger. I think this is bigger. Above 1 is bigger, of course. Just a minute. Yes, above 1 is always bigger. So this would cancel this whole term. Then I'm left with 56 into 55 into 51 minus r is equals to 30800. So let's cancel by 7 first. So let's uh, do that for 28,400. Let's cancel with 8 now. I hope it does work. 550, and this gives me 10. So 51 minus r is equals to 10. So r becomes 41. Okay. So we have a value of r, right? So we can find it out. 41 P2. What are they asking me? 41 P2. So 41 into 40, right? This is what it is. So I hope you get it. The basic calculations from algebra that you got here. Moving on. Let's see what the further part says. Three men have four coats and five waistcoats, six caps. How many ways can he wear them? To use the concept and understanding of permutation arrangement to find the answer. Excuse me. So what do we mean here is कि हमें चार कोड दिए हैं पांच वेस्ट कोड दिए हैं छह कैप्स दिए हैं और हम उनका कॉम्बिनेशन सॉरी कॉम्बिनेशन निकालना है राइट तो थ्री मैन हैव टू वेयर इट राइट तो हमारे पास चार चॉइसेस है जिसमें से हमें कोई सी तीन लेना है right? And P1 can be different, right? So we have to select as a permutation will be. So we write P into 5 P3 into 6 P3. As simple as that. Here, why we have taken P and not P? Some people might have said, yeah, तीन में the same ही होंगे, but no. Their position and their order would change, right? The code and the pattern would change for each of them. So not a P. Now, changing we have, suppose 8 people enter an event in a swim many ways for the goal, several broke the order. I have to choose 3, so 8, 7, 6, as simple as that. Now also I like to tell you 8P3 is also nothing out of the box, right? This is basic property that we have for permutation. Next, I'm really scared that this came in JEE advanced, like guys, come on. Next question we have another concept, we can just make a note of it. Following two steps are involved in the solution of a permutation problem. Recognizing places involved in the problem. Checking whether the repetition of the object is allowed or not. Yeah, this is very important. This is, I would also suggest you that repetition is something that you should check if the repetition is allowed or not. If it's not allowed, then moving forward, like it could change the direction of your question. So moving to the another part we have recognizing the objects and places involved in the problem. Okay, done that. Uh, Yes, so getting back to the lecture, I was sorry for the interruption. So let's see permutation with repetition. So these kinds of problem occur with repetition, permutation of different objects in which some of the objects can be repeated. Number of permutations of different n objects taken r at a time with each object may be repeated in any number of times if n to the power r. It's very easy to understand this why we have taken n to the power r because repetition is allowed, right? If we have n choices, then we can take n for each case. So our results become n to the power r. Let's see an illustration so you'll understand कि हम क्या कहना चाह रहे हैं. So a student appears in an objective test which contains 10 multiple choices. Each question has four choices, in which one is the correct option. A student appears in an objective test which contains 10 multiple choice questions. Each question has four choices, in which one is the correct option. What is the maximum number of different answers that can the student give? How will the answer change if each question may have more than one correct answer? Okay. तो हमें दे रखा है बेसिकली हमारे पास 10 एमसीक्यूज है और हर एक क्वेश्चन के चार ऑप्शन है राइट तो हमें आंसर्स निकालना है ठीक है हर के तो हम हमारे पास क्या हो सकता है हम कोई सा भी ऑप्शन ले सकते चूज कर सकते हैं अब कितनी बार चूज कर सकते हैं 10 टाइम्स तो वो तो हो जाएगा 4 to the power 10 as simple as that. And for the second part, suppose the choice is denoted by ABCD and now choices are either correct or incorrect. Okay, this is something very interesting. I just read through the solution. I suppose you should also read it through. What are they trying to say कि अगर multiple answer correct हो सकते हैं चार options में तो हम देखते हैं चार options में क्या क्या possibility है कि वो दोनों correct हो सकते हैं या दोनों incorrect हो सकते हैं right तो इसके अंदर what they trying to say इसके अंदर एक ऑप्शन हाँ तो क्या हो सकता है हम देखते हैं फॉर एवरी ऑप्शन हमारे पास दो चॉइसेस है अब इस केस में कि या तो वो सही हो सकता है या तो गलत हो सकता है बट तो हम उसके केसेस नोट कर लेते हैं तो चार ऑप्शन है तो 4 बार 2 हो जाएगा टू चॉइसेस आएंगे तो हमारे पास 16 बट हियर हमने एक चॉइस वो भी ले ली है जहाँ पे सारे ऑप्शन इनकरेक्ट होंगे वो भी इंक्लूड कर दिया तो उसको सब्ट्रैक्ट कर देता है तो वी हैव 15 ऑप्शन and now 15 options for each question. तो हमको 10 से मतलब 10 times multiply कर देंगे तो we'll get our answer. Okay. Moving on, we have another concept for our side. The m to the power n and n to the power n dilemma. Okay, this can be sometimes tricky for students to study. So let's say इसका क्या है? Let us start with an example. There are n letters and 5 letter boxes. In how many ways can you put a letter in a letter box? Okay. तो हमारे पास हर एक लेटर को हर लेटर के लिए पास कितने ऑप्शन है कहाँ का डालने के ऑप्शन है 5 ऑप्शन है तो 7 टाइम्स रिपीट होगा राइट एक बार अपन देखते हैं व्हाट इज द एग्जॉस्टिव लाइक व्हाट द पर्सन इज ट्राइंग टू स्पीक हियर this is typically confusing question ranks frequently from PNC and PNC area. Let us see how we can solve this type of question. When one way to solve this question is through what we call the exhaustive approach. While solving such problems, first decide which of the items is exhaustive. Exhaustive here means the identity is here to be used up completely. For example, letters are to be placed in the box, whereas there is no such constraint with regards to letter boxes. That's exactly what I also think too, but I could not place words into it, right? So one is very like one has to be very careful while selecting कि कौन सा independent और कौन सा dependent है. So this exhaustive approach is very good. So कि exhaustive मतलब कौन सी चीज खत्म हो सकती है और कौन सी नहीं. कि लेटर्स इस केस में खत्म हो सकता है बट अपने लेटर बॉक्सेस का भी खत्म नहीं सकते राइट लेटर बॉक्सेस की कैपेसिटी इज नॉट मेंशन तो किसके भी लेटर्स भर सकते हैं अपन उसमें बट लेटर्स आर एग्जॉस्टिव इन दिस केस राइट so letters are to be placed in the boxes where there is no such content of the letter boxes some letter boxes could go empty Having decided this, just go by the option having the instances of exhaustive item, you have the answer. तो वो ये है कि हमें 5 लेटर बॉक्सेस में चूज करना था ना हर एक लेटर के लिए, तो हमारे पास 5 चॉइसेस थी और वो हर लेटर के लिए डिफरेंट है, तो हम उसको 7 टाइम्स मल्टीप्लाई कर देंगे, we get an answer. Also, guys, practice is the best approach here. How much you like learn and do this person also himself must have learned through कि practice के through develop किया होगा ना. He cannot get a sixth sense कि हाँ ऐसे करने से होता है. It's more about practice. If you practice, this would come into your work by yourself itself. Now, permutation of alike objects. So, alike का मतलब है कि सारे objects एक जैसे हैं. ठीक है. दिस इज ऑल्सो वेरी समथिंग दैट वी शुड डिस्कस कि ऑब्जेक्ट डिफरेंट और सेम होने में भी काफी फर्क पड़ता है ऑन द नंबर ऑफ वेज दैट यू आर सॉल्विंग अ क्वेश्चन. अगर ऑब्जेक्ट सेम है तो वो परम्यूटेशन अलग हो सकता है, और अगर ऑब्जेक्ट डिफरेंट है तो परम्यूटेशन अलग हो सकता है. फॉर एग्जाम्पल देखते हैं अपन. This kind of problem involves permutation of different objects in which some of them are similar. The number of permutations of an object taken all the time in which P are alike, of one kind Q are alike, and second R are alike. Okay, तो हमारे पास n सेट्स है, उनमें से कुछ P एक जैसे हैं, Q एक जैसे हैं और R एक जैसा है. तो नंबर ऑफ वेज ऑफ गेटिंग these ना is n factorial, P factorial, Q factorial, R factorial. It's as simple as that. And also there's a condition here कि जो बचे हुए ऑब्जेक्ट्स है n माइनस पी प्लस क्यू प्लस आर, ये सारे डिफरेंट है. So there is like condition applied here. So this is something you should remember. I'll highlight this for you guys. Okay. Now moving on, let's do a question over the same. Determine the number of permutations of the letter simplification. Simplification, right? Simplification का हमें permutations करना है. So let's see. Taken all at a time, right? So how do we do that? Let's count the number of letters here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 letters, so this would come. But now some letters are being repeated, right? So I अगर repeat हो रहा है दोबारा तो हम उसको दो से कर देंगे ऐसे. Now और कोई letter repeat हो रहा है आपके नजर में? नहीं, right? So this is what we are left with. Cool. Let's use the theory also to get a better understanding. We have in a given word, the letter I occurs twice and the remaining letters occur only once. So the concept of permutation of alike objects too is used to find out the answer. There are 10 letters of the word simplicity, and out of these 10 letters, 2 are identical. So just selecting all 10 objects at time will give us twice the actual result. Hence, the number of permutations taken all letters at the time is P10P by 2 factorial. I hope you got the English here. Now, moving on. Moving on to the next question. Just wait upon me. Permutation and the restrictions. Okay, this is something that JE always asks us. There is always a restriction, और उस condition के ऊपर हमें कैसे apply करना है, something you develop with time. So let's see what conditions we have here. So number of permutations of n different objects taken are at a time where a particular object is always to be included in the arrangement. Okay. एक पर्टिकुलर ऑब्जेक्ट हमेशा ही होना चाहिए, तो हमने उसको पहले से डाल दिया उसके अंदर, राइट. अगर हमारे पास आर आर टाइम लेना है तो आर हमारे पास हो गए इतने स्पेसेस, और हमने उसको हमेशा से एक चीज को फिल कर रखा है, तो हमारे पास टोटल सेट कितने बचेगा, एन माइनस ऑब्जेक्ट का सेट बचेगा, और हमारे पास ऑप्शन कितने बचेंगे, आर माइनस वन बचेगा, राइट. तो हम उसको कैसे लिख पाएंगे, टी माइनस एन माइनस वन टी आर माइनस वन. यू गेट इट. Now moving on to the next part, what do we have here? We have the number of permutations of n different objects taken are at a time, or when a particular object is never taken in arrangement. तो वो बहुत ही आसान है, अगर एक ऑब्जेक्ट हमेशा नहीं लेना अरेंजमेंट में. यू राइट n माइनस वन, बिकॉज वो सेट में है ही नहीं इंक्लूडेड, तो वी डू नॉट यूज दैट. नाउ स्ट्रिंग मेथड. The number of permutations of n different objects taken all at a time when m specified objects always come together. Always come together मतलब हमेशा साथ में आते हैं, राइट? अगर इसका हम केस लेके चले, फॉर एग्जाम्पल ए बी सी हमेशा साथ में आते हैं, तो ये हमेशा साथ में रहेंगे, राइट? So now we are left with how many places? n minus m. अगर ये m है, बट हम इसमें एक और ऐड कर देंगे बिकॉज ये एक बिग ऑब्जेक्ट की तरह काउंट होगा ना अब, तो इसको, और अभी साथ में रहेंगे तो ये भी कम्यूट हो सकते हैं एक दूसरे के अंदर। समझ पा रहे हैं आप थोड़ा, लाइक इसका क्या कहना चाह रहा हूँ मैं, कि अगर हमारे पास एक चीजें साथ में रहेंगी तो वो, जैसे कि एक एग्जांपल लेते हैं, फॉर एग्जांपल हमारे पास चलो वर्ड्स ही लेते हैं, अगर हमारे पास वर्ड्स है मैथमेटिक्स, और हमें चाहिए कि मैट्रिक्स साथ में रहना चाहिए, ठीक है? साथ में रहेगा बट कम्प्यूटेशन कर सकता है, तो देखिए अब अपने पास कितने ऑब्जेक्ट हो गए, एम ए टी एच ई, और एक ये ऑब्जेक्ट और एस है, तो इसको देखते हैं 1 2 3 4 5 6 7, तो 7 परम्यूटेशन, 7 मतलब 1 2 3 4 5 6 7 8 9 10 11, 11 -5 +1, इससे परम्यूटेशन हो गए, बट ये पांच भी खुद में परम्यूट हो सकता है, इधर उधर हो सकता है, तो व्हाट आर वी लेफ्ट विथ, n minus m plus 1 m. Get it what I'm trying to say? I hope this clears you up. This is this method and this explanation is, I suppose, would be clear for you guys. Now moving on, gap method. The number of permutations when two given objects occur together. In order to find the number of permutations when no two objects are occur together, first of all, put the m objects for which there is no restrictions in a line, and the m objects can be arranged in m ways. Okay. Then count the number of gaps. Okay, yes, I got the method. I was just reading through for you guys. Let's read the complete steps and then we'll see. The count, then count the number of gaps between every two m objects for which there is no restriction, including the n position. The number of such gaps would be m plus 1. M is the number of objects for which there is no restriction, and n is the number of objects, so two of which are not allowed to occur together. So then the number of ways is m factorial into m plus 1, and for and n factorial. Yes. N is the number that cannot come together, right? I think there is a mistake here. N is the number of objects. No, I got it. What we are trying to say. Okay. So first, what do we do is we take the, okay, what are we doing is we're taking two of n objects from the gap. So let's just write the dash part here. What are we trying to do? ओके, तो अगर हमारे पास एम ऑब्जेक्ट है जिनके ऊपर हमारे पास कोई रिस्ट्रिक्शन नहीं, तो हम उसको एम परम्यूटेशन में से डाल सकते हैं। अब हमको एन गैप चूज करने हैं एम प्लस वन गैप से। जैसे कि अपन देखते हैं, अगर हमने यहाँ पे एम ऑब्जेक्ट प्लेस कर दिए जिन पे कोई रिस्ट्रिक्शन नहीं है, और उसके बाद हमारे पास ये गैप्स है, तो नंबर ऑफ गैप्स कितने हो जाएंगे, एम प्लस वन। और अब हम उनमें से हमने कोई से भी एन चीजें चूज कर लिया और उन एन चीजों को भी परम्यूट कर दिया, राइट? तो इसको हम ऐसे भी लिख सकते हैं, एम factorial m plus 1 p p m plus 1 pn, because m plus 1 pn n factorial is equal to m plus 1 pn. I hope you get it. This is interesting, guys. Like, I hope you remember this. इससे क्वेश्चन करेंगे तो आई होप मोर थिंग्स विल बी क्लियर फॉर अस, बट इसको अभी अपन हाईलाइट कर लेते हैं फॉर फ्यूचर रेफरेंस एज वेल। नाउ मूविंग ऑन, लेट्स रीड इट। The number of commutations when two of the objects are arranged alternately, then the numbers differ by one for the objects whose number is greater in the first, third, fifth place, etc. And the other object is second, fourth, sixth places. Okay. If the number of two types of objects is same, consider two cases separately, keeping the first type of the object in the first third places and the second type in, oh, there is a mistake. It should be second, fourth, and sixth here. So I think there is a mistake here. We'll check it out. So non-consecutive selection. Number of selections of R consecutive objects out of an object in a row is, okay, अगर हमें R consecutive चीजें लेनी है, जैसे कि हमारे पास 6 चीजें हैं और हमें उनसे दो consecutive लेना है, तो 1 2 3 4 5, राइट. अगर हमें तीन लेनी होती है, लेट्स रेज इट अप अ बिट, 1 2 3 4 5 6, और तीन लेनी होती है, तो 1 2 3 4, मतलब 6 minus 3 plus 1, that is 4. टू में क्या आंसर था हमारा, 1 2 3 4 5, 5, right? So 6 minus 2 plus 1, this gives me 5, and this had already given me 4. We get our values right? So moving on. This is very easy, so guys. Like, I am just being basic with you because we were told to like cover the basics, right? So इसलिए हम basic cover करेंगे अभी. Now, the number of selections of R consecutive objects out of n objects along a circle. Okay, अब now we have a circle here, right? So अगर हमारे पास objects है 1 2 3 4 5 6, and now we have to like select any number of like things for R less than n. तो इसके n तरीके से let's go. अगर हमें दो चीज select करनी है consecutively, 1 2 3 4 5 and 6, right? So these are again n. तीन भी करनी है तो भी we have n choices. N choices मतलब 6 choices. So I hope you remember those. This is also something that you can remember. Okay. So do we have a time for covering combination as well? Let's see. Let's just go about combination right now. उसके बाद हम कुछ questions करने की कोशिश करेंगे, ठीक है? So for combination, I'll tell you what combination basically is permutation, but permutation where the relevance of arrangement, the order is lost. मतलब हमें order से फर्क नहीं पड़ता कि किस order में हमारे objects place करें हमने. एक बार हम मतलब इस combination is more about selection of objects. So that is very important for us to understand. So each of the different groups or selections which can be made by some or all of a number of objects of given objects without reference to the order of the objects. This is very important to understand कि यहाँ पे order की कोई value नहीं है, right? There is no importance that we give to the order. So how do we write NCR? NCR is equals to n factorial by r factorial by n minus r factorial, right? This, it is NPR, right? NPR upon n minus r. Oh, sorry. This is a NPR, guys. My bad. N factorial, n minus r factorial, and r factorial. This is NPR. So we'll write here r factorial, right? So let's see what does the theory say. And also there are a number of applications over this as well. This part. Yes. That NCR is equal to, just wait a minute. I wrote 833 and 835 as same. So it is wrong. Guys, just a minute. Let's go back to a question and let's see what the question was saying then. We'll just come back later on to the different part. This, right? What was the question? This part, yes. No. This question. Okay. Okay, I understood what was the problem there. But I went with the right solution, right? So there is no harm there. Let's come back to the combination part. So we know what the combinations looks like, right? So moving on to some properties. So what properties are there? Let's highlight it for you guys. So just read it through. I don't think I'll have to explain you because this is very simple properties that we're trying to do. Some of them, may need a proof, but I don't think that's relevant for the time being. जैसे कि for the first property is very direct and simple. Let's go about the next property. We have n factorial r factorial n minus r factorial plus n factorial r minus 1 factorial into n minus r plus 1 factorial. So let's do this. Now अगर हम इसको एलसीएम में लेते हैं ना तो कॉमन चीजें पहले निकाल लेते हैं अपन n फैक्टोरियल कॉमन ले लेते हैं n माइनस r फैक्टोरियल कॉमन ले लेते हैं और n माइनस r फैक्टोरियल कॉमन ले लेते हैं वी आर लेफ्ट विथ r एंड यहाँ पे हमारे पास क्या बचेगा n माइनस r प्लस वन अगर हम इसको सॉल्व करते हैं तो हमारे पास आएगा n माइनस r प्लस वन प्लस r अपॉन r इंटू n माइनस r प्लस वन तो r and r gets cancelled तो हमारे पास n प्लस वन बचता है so it becomes n plus 1 का factorial upon r factorial and n minus r plus 1 का factorial. So you get it's very simple derivation, guys. Nothing out of the box. Simple algebra, and you take LCM, so you will get what the formula is. But I would suggest you to remember the formula because ये आगे जाके direct solve करने में बहुत help करेगा questions को, right? Now moving on to the next property. If you have some time, we'll go about it. अगर हमें दे रखा है कि एन सी एक्स इज इक्वल टू एन सी वाई तो हम दो चीजें कर सकते हैं या तो एक्स इज इक्वल टू वाई होगा या तो उनका सम एन होगा लाइक डायरेक्ट अरे डायरेक्ट कनेक्शन टू दिस प्रॉपर्टी राइट नेक्स्ट अगर हमारा एन इवन है then the greatest value of NCR is equal to NCN by 2 okay अगर हमारा n odd है then the greatest value of NCR is given by NC n plus 1 by 2 this is something that you can remember. Now getting back to this, NC0 plus NC1 plus NC2 till NCN is equals to the power n. Okay. And NCN plus n plus 1 Cn n plus 2 Cn gives us 2n C n plus 1. तो देखो f वाली जो प्रॉपर्टी ना आई हैव अ वेरी इंटरेस्टिंग वे ऑफ डूइंग दिस क्वेश्चन ठीक है अगर आप इसको ऐसा सोचो कि कॉइन को टॉस किया है पहले ठीक है एक कॉइन को टॉस किया है एन कॉइन्स को टॉस करते हैं चलो ठीक है अपन एन कॉइन्स को टॉस किया है और हम प्रोबेबिलिटी निकालते हैं हर एक की क्या प्रोबेबिलिटी होगी कि वो एक एक भी रिजल्ट आए और सारे हेड्स या फिर सारे टेल्स हो चलो ठीक है अपन एक कंडीशन लेके चलते हैं ऐसा वाले को गिव यू वेरी लॉजिक रीजन बिहाइंड इट अगर हमारे पास एन कॉइन्स है और हमें निकालना है टेल्स टेल्स की प्रॉपर्टी क्या हो सकती है ठीक है प्रोबेबिलिटी क्या हो सकती है तो अगर हमें जीरो टेल्स चाहिए तो उसकी प्रोबेबिलिटी क्या होगी एन सी जीरो अगर हमें एक चाहिए तो क्या होगी एम सी वन और ऐसे करके एम सी एन होगी इन सब का सम हो जाएगा राइट और अगर हम इसका एक और पॉइंट ऑफ व्यू देखें कैलकुलेट करने का प्रोबेबिलिटी तो हर कॉइन के पास कितनी प्रोबेबिलिटी है टेल लाने की उस मतलब कॉइन के पास कितने ऑप्शन है वो तो हेड आएगा या टेल आएगा राइट तो नंबर ऑफ कितने हो सकते हैं अपने पास नंबर ऑफ पॉसिबिलिटी और नंबर ऑफ वेज कैसे सकते हैं मतलब उसमें प्रोबेबिलिटी नहीं निकालनी हमें वेज निकालना ठीक है एक और चलो लेट्स आई जस्ट मेस इट अप बट हम इसको वापस देखते हैं हमारे पास कितने इवेंट्स हो सकते हैं जहाँ पे सिर्फ एक भी टेस्ट रहा है एन सी जीरो जब एक टेस्ट आए एन सी वन जब दो टेस्ट आए एन सी टू और ऐसे करके एन सी एन टेस्ट सारे टेस्ट होते हैं एन सी एन हो जाएगा उसी केस में हम सारे अगर निकालना चाहें तो क्या हो सकता है आउटकम राइट है ना वो आउटकम क्या हो सकता है हर पॉइंट के पास दो ऑप्शन या तो हेड आएगा तो टेल आएगा तो दो ऑप्शन और कितने पॉइंट है एन so this is a very logical explanation of this probability बाकी आप इसको फिजिकली सॉल्व करके भी देख सकते हो इट्स वेरी इजी लाइक बट आई वुड सजेस्ट यू कि थोड़ा सा लॉजिक लगा के चलिए कॉम्बिनेशन ऑफ ऑपरेशन कैन सॉल्व अ वे लाइक लास्ट नंबर ऑफ क्वेश्चंस फॉर यू just by the means of logic so I still keep the logic in your hand I will skip the these property for the time being because I don't want to waste my time on the properties because we have to like do some questions as well. Okay, now comparing between permutation and combination. So permutation is basically different ordering or arrangements of our objects are permutation are different permutations. Each choice or subset of our object gives one combination order within the group of our objects does not matter. Highlight point for combination. The order does not matter. Moving on. Let's do just one more example. We can take two more examples, I suppose. A basketball coach must select two attackers and two defenders from among three attackers and five defenders. How many combinations of attackers and defenders can be selected? See, अब यहाँ पर क्वेश्चन भी थोड़ा सा हमें हेल्प करने की कोशिश करें कि कॉम्बिनेशन निकालना है, ठीक है? तो यहाँ पे हमें ऑर्डर का मतलब नहीं है, तो इसे कैसे कर सकते हैं? हम तीन में से दो ले लेते हैं और पांच में से भी दो ले लेते हैं, सिंपल। नेक्स्ट, soccer team of 11 players is to be chosen from 30 boys, of whom 4 can only play in goal, 12 can play as forwards, and the remaining 14 in any other position. And the team is to include 5 forwards and of course one goalkeeper, in how many ways it can be made. Okay. तो हमें क्या करना है? 12 लोगों में से किसी पांच को चुनना पड़ेगा, चार में से एक को चुनना पड़ेगा, और बाकी 14 में से किसी भी पांच को चूज कर सकते हैं अपन। नेक्स्ट, combinations under restriction. This is also property and like important part. Let's see, let's cover this up and we'll end it over there. Number of ways choosing R objects out of n different objects if the particular objects must be excluded. Consider the objects A1, A2, A3 and AP, AP plus 1 and AN. If three objects A1, A2, AP are to be excluded, then we'll have to select R objects from the remaining n minus P objects. Okay, and hence the number of required ways is this. Okay, very easy. अगर हमें किसी see exclusion is something that can be understood very easily. अगर कोई भी ऑब्जेक्ट को एक्सक्लूड करना है तो आप उसको टोटल सेट में से एक्सक्लूड कर दो, ठीक है? जैसे कि अगर हमें पी ऑब्जेक्ट को एक्सक्लूड करना है तो पूरा जो आपका टोटल पेरेंट सेट है एन, उसमें से पी को रिमूव कर दो। नेक्स्ट, number of ways of choosing R objects of out of n different objects if P particular objects must be included, ठीक है? हम R ऑब्जेक्ट चूज करना है और उनमें R इंक्लूड होने ही चाहिए, P इंक्लूड होने ही चाहिए हमेशा। अगेन आपने P को हमेशा जगह दे दी यहाँ पे, तो ये हो जाएगा। नंबर ऑफ, ये हमने ऑलरेडी उसको ही देखा था कॉम्बिनेशन में, इट्स नथिंग डिफरेंट। टोटल नंबर ऑफ कॉम्बिनेशंस ऑफ n different objects taken one or more at a time। अगर हमें n डिफरेंट ऑब्जेक्ट्स को लेना है और हम उसको रिपीट कर सकते हैं, तो क्या हो सकता है? या तो हम एक ऑब्जेक्ट को ले या ना ले, एक और चॉइस ऐसे ले लें, बट हमें एक ऑप्शन इसमें घटाना पड़ेगा जब हमने किसी को भी नहीं लिया। एक ना एक को तो लेना ही पड़ेगा ना, एक को तो लेना ही है। अगर जीरो और मोर होता तो टू की पावर एन कर देते हैं, बट एक को तो लेना है तो एक केस को सब्ट्रैक्ट करना पड़ेगा, ठीक? आई होप वी कवर अप ऑलमोस्ट द थ्योरी पार्ट ऑफ इट। बाकी अगर होता है तो we'll just try to cover it in different lecture. Hmm. So thank you guys. I'll just wrap up the lecture by this and see you in tomorrow's class if there's any.